Hey guys, what's up everyone? So in this video we'll discuss about this problem, longest common subsequence. Given two strings text1 and text2, return the length of their longest common subsequence. A subsequence of a string is a new string generated from the original string with some characters, can be none, deleted without changing the relative order of the remaining characters. Example, ACE is a subsequence of ABCDE while AEC is not. A common subsequence of two strings is a subsequence that is common to both the strings. If there is no common subsequence, return 0. So let us consider this example. So in this example, text 1 is ABCDE and text 2 is ACE. The output is 3 because the longest common subsequence is ACE and its length is 3. So as you can see, ACE exists in text 1 and ACE exists in text 2 as well. So let us see how we can solve this problem. So this is a very common dynamic programming question, but before moving to the dynamic programming approach to solve this problem, let us first try to find out the recursive approach to solve this problem. So let us consider that we are given two strings, text1 and text2. Now I'm going to write a recursive method, and in the recursive method I will be providing the two strings text1 and text2 and two more variables I and j, which will point to the current character being processed for text1 and text2 respectively. So let us consider the recursive method name is LCS, and we will be providing text1, text2, I and j. Now there exist two cases. The first case is in case the current character for text1 matches with the current character for text2. So as you can see over here, the current character for text1 matches with current character of text2. What we will be doing is we will be calling the recursion for the rest of the string for text1 and rest of the string for text2, and we will simply add 1 to it. Why 1 to it? Because we have already found a common character between text1 and text2. So this is written over here. In case the current character matches, we will be calling the recursion for I plus 1, j plus 1, and we will be adding 1 to it. The next case is when the current character does not match. As you can see in this example, the current character is not matching. So in this case, we will be calling recursion two times. In the first time, we will be calling it for the entire text1 string and the rest of the string for text2. The second recursive call is going to be the entire string for text2 and the rest of the string for text1, and we will return the maximum out of it. So in case the correct character does not match, we will be calling recursion for I plus 1 j and ij plus 1, and we will return the max value out of it. So let me write the code for it, and then things will be more clear. So let us first check for the null conditions, that is in case text1 equal null or text2 equal null or text1 dot length equal 0 or text2 dot length equal 0, we can simply return 0 from here. Now what I'm going to do is I'm going to write a recursive method LCS, and I will be providing the current text1, current text2, I and j. So I'm passing 0, 0 because I'm going to iterate the strings from the beginning. So let me write this method LCS, which have string text1, string text2, int I, int j. Now two cases exist as already mentioned. In case text1.char I matches with text2.char j. So in case it does, we'll simply call recursion for text1, text2 with I plus 1, j plus 1, and we'll add 1 to it. And the second call is in case the current character does not match, we'll call recursion a couple of times and we will return the max value out of it. The first is text1, text2, I plus 1, j, and second is text1, text2, I, j plus 1. Correct? Let me add the base case for this as well. In case I equal text1 dot length or j equal text2 dot length, we will simply return a 0. Why a 0? Because in case I or j has reached the maximum of text1 and text2, there is nothing left in text1 and text2, so there is no point of finding a common subsequence when the string is completed. So that's why we are returning a 0 out of here. So let me just run this code and let me just submit the solution. So this is giving us a TLE. So let us try to find out why. So what I've done over here is I've considered another example and I have created a recursion tree for this. This is not the complete recursion tree, this is just a part of it. What I want to point over here is, as you can see, there is a call for LCS 1,1 and LCS 1,1 at two different positions. What it means is the same problems are repeating and we are trying to find the same problem again and again. So this is adding to our complexity. So what we can do in this case is, when we have called LCS 1,1 for the first time, we can store this result at some place, and instead of calling it again, we can just refer it from that table or the place where we have stored the result. So what we will do is, we'll just create a DP array over here. And why is the DP array a two-dimensional array? It is because there are two states of DP. Why is that? Because there are two variables in the problem. Correct? That's why the DP array is two-dimensional. So we will just check over here, if DP of ij is not equals to -1, then we will simply return DP of ij and we will save the value at DP at ij. So from here we have to pass the DP array. So we have to define a DP array over here as well. So before this, let me just write int m equals text1 dot length, int n equals text2 dot length, and we will create a DP array of size m cross n. Okay, why m cross n? Because we are calling it for dpij. So as you know, for I and j, the maximum values are going to be m comma n. So that's why we are creating a DP array of size m cross n. So we'll just initialize this DP array with -1. So we'll iterate over this array, int I equals 0, I less than m, I plus plus, for int j equals 0, j less than n, j plus plus. We will simply say DP of ij equals -1. Don't forget to pass DP in this recursive methods as well. So now what we have done is, we've created a DP array over here. We have passed the DP array in the method. So whenever we are calling a recursion, and whenever we are back from the recursion, we are storing it at dpij. Similarly, over here as well, we are storing it at dpij. And before calling our recursion, we are checking whether dpij is not -1. In case it is not -1, then it means that we have stored some value and we will return that value. So as you can see that we are calling recursions over here. This is recursion. This is recursion. This is recursion. And before calling the recursion, we are trying to find out whether we have value for dpij. So it won't call recursion unnecessary. So let me just run this code. So it's giving the correct result. Let me submit this solution. So it got accepted. So I guess that's it from this video. I'll try to make one more video with a bottoms up solution for the DP, and we'll try to optimize the space. So I guess that's it from this video. In case you have learned anything from this video, you can hit that like button, and in order to support my work, please subscribe to my channel. Thank you all.